Hello, everyone, and welcome to today's webinar, which we added to our lineup after the user group spring conferences were canceled. So this is actually the first of two webinars we'll be hosting this month. We're certainly glad you're able to join us. I'm Denise, and with me to present is QAD and MRP expert Don Lindsay. Before I hand off to Don, please know that everyone connects to the webinar already muted, but you can type in your questions or comments at any time throughout the session. Type them into the bottom of your control panel there where you see the red arrow pointing, and then during the Q&A, I will read the questions, if any, in the order received. Okay, and now I will hand off to Don Lindsay, who probably needs no introduction, but just in case, as a business analyst, and as you can see, much, much more, Don has 18 years of QAD ERP experience and has worked among 7 different versions of QAD. So Don, whenever you are ready.
Okay, so good morning or afternoon, depending on where you are this fine April 8th of 2020. Thank you, Denise, for that gracious introduction. As Denise indicated, because of the coronavirus, MUG, the West Coast user group, the Southeast user group, and Explorer have all been canceled for their spring sessions. I had prepared this particular presentation, MRP, How to Make It Fail, which I was going to give at both MUG and the West Coast user group this spring. So Alex and I thought that since the supply chain is so much in the news and MRP is such an integral part of the supply chain, we would present this as a webinar. Speaking of coronavirus, last Tuesday, I had the opportunity to listen to a presentation by the Apex Inland Empire chapter here in Southern California titled Weathering the Coronavirus Pandemic's Impact on Global Supply Chains. Alan is the president of GDI Consulting, and I've known Alan for over 30 years. He's a very qualified senior supply chain consultant. He's on the board of directors of the National Apex chapter and the Association of Supply Chain Management. He's on the board of directors of several aerospace and manufacturing organizations. And basically, his bottom line of the presentation was that there's probably going to be a significant depression in the coming quarters. 30% unemployment, 50% reduction in GDP, probably a 50% chance of a credit freeze with much disruption to the global supply chains. One of the primary points that I got out of the presentation was how important the supply chain is and will be in the quarters ahead. The supply chain is going to be critical to recovering from this pandemic that we're engaged in. So if at the end of the session, you'd like to have a copy of Alan's presentation or want more information, just drop Denise and I a email. The purpose of the presentation today is how does MRP in QAD work? And as opposed to the negative of the title, what causes MRP to work properly? So we're going to cover a fair amount of information today in regards to what MRP is. Again, we always point out terminology. If you don't know a term that we're going to use, please give us a line and we'll try and explain it. You need to have some solid work instructions for everything we're going to talk about and hopefully a company data dictionary. Remember, Mowgli requires work instructions and data dictionaries for their processes. So a little bit about ERP and MRP. It was invented back in the 1950s when IBM developed the bill of material processor. Joe, Ollie, George Plossel got together. They figured out how to do this time-phased explosion of the bill of material. This is called MRP, and it's basically the way of life of planning now for ERP systems. I did a couple of presentations last year on DDMRP, which I would highly recommend you become familiar with. But basically, MRP is in most of our MRP systems, and today we're going to talk about how that works with QAD. You can see from the Apex body of knowledge MRP flow chart that starts off with business planning, works down to marketing, production planning. You check resources, master scheduling drives into MRP, MRP drives capacity, and then down into the execution phases of the closed loop system. So MRP is basically at the center of this whole ERP process. In addition to all of the other accoutrements that we have become familiar with, CRM, Internet of Things, APS. So MRP is the primary tool that we're going to use. If you look at QAD, you can see that that whole ERP structure is represented by the main menus that are in the QAD ERP environment. We're going to concentrate primarily on manufacturing today, but some of the others also. So what's the basis of MRP? It's, as we said, the time-phased explosion of the bill of material based on the master production schedule to determine what and when we need to buy and build product. It's based on the bill of material. Here you can see a simple bill of material. A takes B, C, and D. B takes E and F. C takes G. And E takes G, F, and H. So as opposed to what we might commonly think, that a bill of material is simply a parent and a list of all the components, it's not really. What exists in the data table, PS master, is a whole series of parent-child relationships. In this case, we've got 9 records. They're horizontally related and vertically related. The purchased items in this particular little bill are G, F, H, and D, and the assemblies are A, B, C, and E. If you look at that, we can tell that the lowest level that a particular item exists in any bill of material in the system. You can see here that G goes into E and G goes into C. The low-level code of G is, in this case, going to be 3. So MRP, this BOMs processor, calculates the number of G's required to build A's so that we can see that we have a need of 24 G's as a gross requirement. The typical bill of material data elements are parent component. We'll go through that a little bit more later. And basically, all of those kinds of bills of material lists or reports that we see are made up of these parent-child relationships. For MRP, we simply turn that bill of material on its side. We've got a due date for the final assembly, an offset or a lead time that it needs to be built in. And that means that the 2 components of the final assembly, in this case, subassembly B and subassembly A, are needed on the start date of the final assembly. We can work our way back through all of the bill of material parent component relationships so that we ultimately come up with what is called the cumulative manufacturing lead time. So this is basically how MRP works. If we look at the process itself, see here we've got an X that takes 1 and 2, a Y takes 1 and 3, and we've got a master schedule for 1. We can see that you can derive the gross requirements for that part number 1 by simply looking at all of the sources of demand to come up with our gross requirements. The quantity on hand minus the allocation says that we've got 60 at the beginning of, or at the end of period 1. We're going to go into period 2, subtract the 40 gross requirements. We've got 40 requirements in period 3, but a scheduled receipt in period 3 of 100. So our net our projected quantity on hand is 80. We can carry that out. Now we've got a projected quantity on hand of -10, and that says that we've got a net requirement, which includes, in this case, the safety stock. We're going to plan the receipt of an order in that period to satisfy that net requirement, offset it by the lead time, and it's going to come in, and our new projected quantity on hand is going to be 90, and that 90 is going to carry. So that's basically how MRP works, along with, and we'll discuss most of these issues in the remainder of the session. We've got the MRP explosion process, which is 23.2, which is the regenerative material requirements plan. You can also do a net change plan or a selective. If we remember from our previous discussions in 1.4.7, the item planning maintenance, if this field MRP required is checked, that means the system has determined that it needs to have a new explosion processed to recalculate the MRP plan. Gross requirements in MRP are basically the accumulation of demand at the part number level, and that can come from exploded parents, forecast allocations, customer schedules, sales orders. Scheduled receipts in MRP are basically what we call open orders or paperwork released. We'll see that MRP doesn't automatically reschedule this, but MRP does suggest reschedule messages. The projected quantity on hand is calculated as the quantity in period T plus the scheduled quantity in T minus 1 plus the scheduled receipts in T minus the gross requirements in T. So the first period says we take the on hand minus the allocations minus gross plus scheduled receipts plus planned orders gives us our projected quantity on hand. At the other periods, we see again that the formula is T, quantity on hand T, T minus 1 plus the scheduled receipts minus gross requirements. So the computer loves these sets of calculations. The net requirement is basically where you see a negative projected quantity on hand. If the system has a negative projected quantity on hand, that's the same as a net requirement. MRP does not like net requirements, and so therefore it's going to plan an order. A planned order is a system recommendation for additional supply to cover that net requirement. And it is replanned every MRP explosion. If you go into the MRP table, you can see that these planned orders are MRP type equal supply P. The firm planned orders are a different kind of planned order in that it is frozen in both time and quantity. And this is how the master production schedule is processed. If you look at the types of orders, scheduled, planned, or firm planned orders, we see that scheduled orders don't explode and don't reschedule because they're paperwork released. So we don't want to have them automatically recalculated by the system, but you will get messages, expedite, delay, cancel messages. Planned orders do explode and they do automatically reschedule. With the explosion process, it wipes out all planned orders and replans new orders. The firm planned orders explode, but the master schedule has put it in place. So if we look at a simple bill of material, here we got a chair with an arm assembly and an arm rest going into the arm assembly. We can see that we're going to simply bring down those gross requirements from the chair, and the chair arm goes twice into the chair. We've got a scheduled receipt of 50, so we can go through our planning and we see that we encounter a negative projected quantity on hand in period 4. Same as the net requirement, MRP is going to plan an order, it's going to offset it, it's going to come back into inventory, and now we can go through the remainder of those periods, and we can see that by MRP's planning, based on the lot sizing, order minimums and order multiples, we now have planned order releases of the arm assembly of 25, 50, 25, and 50. We're going to bring those down to the arm rest. We've got 10 on hand. We're going to go through that netting process. Now we've got a net requirement in period 3 of 15, and since our order policy is POQ, period order quantity, we're going to go out 4 periods in the future, accumulate those gross requirements, and plan an order. Offset it, going to come into inventory. We're going to go through that process again. Now we can see that MRP is going to have a planned order release of 90 and 60 in that period. So that's basically how MRP order policies work. Allocations in MRP are basically what we call uncashed stockroom receipts. So this is an allocation, says that you've got a gross requirement that is going to be taken into account for that particular item. The effect of allocations in MRP is the timing of those allocations, because you can have allocations detailed out into the future. So that will affect how MRP calculates. The detail allocations to the pick list determine what is physically assigned to the work orders and sales orders. So that's critical to how MRP functions. And the general allocation as a part of the gross requirement in that MRP grid. We can see that MRP assumes a couple of things. Number one, MRP assumes you're going to do what it says. It's just a stupid computer. So if it tells you to do something, it assumes you're going to do it. It assumes you told it the truth. There's the key to how MRP works. You've got to tell MRP how everything that is in your manufacturing organization, facility, and planning system is, and you've got to tell it the absolute truth. We'll talk about the reschedule messages. It's easier to expedite an order than place a new one. If it takes X number of days to complete the work that you've told it in terms of lead time, then MRP assumes that it's going to be accomplished in that time. If it tells you to delay or expedite a scheduled receipt, it assumes you were successful at that and that you have told it everything you know about your system. So let's look at how we can make MRP fail, or how to make it work. Control files. Control files, as we all know, determine how QED is going to process information having to do with particular functionality in QED. If we look at the MRP control file, we can see here that we've got a MRP horizon. There's an order release horizon that tells you how many days in the future you're going to get a notice that a particular planned order needs to be released. You can enable the opt-based yield. We'll talk about that a little bit later. And there's a dynamic lead time fence that you can set for MRP. If you look at regulatory attributes control 122.24, if you set the lot control level, that's going to tell MRP how it needs to explode and plan your components. In inventory, we've got item tolerance for cycle counting and picking order for our shop packets. If you look at the sales order control, we've got allocation limits. Whether you're going to do detail allocations, there's available to promise enforcement and horizons. There's shipping lead time that can offset MRP for you. And do you automatically confirm orders? Because a confirmed order is only recognized by MRP. Unconfirmed are not recognized by MRP. In the purchasing control, we've got tolerance percentages that affect how you're going to update the quantity on hand. And in repetitive control, if you enable the new repetitive, or what we call advanced repetitive, are you going to transfer WIP? How are you going to use GL periods or effectivity methods? And then you can also include yield for your cost calculations. There are many other control files that are affect MRP depending on whether you've got them implemented at your facility, such as obsolete inventory, WIP lot trace, supplier consignment, which we're going to talk about in June, customer consignment, return to material, DRP, Kanban. So there's a whole nother set of MRP control files that you're going to be needing to be familiar with in terms of how your MRP is going to work. There's sales and operations planning. Sales and operations planning is that integrated business management process where marketing, sales, engineering, operations get together every month and they review what the performance was and set the plan or the goals for the master production schedule. If any of you know Dick Lynn, I'd recommend you read some of his. He's called the father of sales and operations planning. He's a very good source of information for S&OP. And if you use QAD, it is in the supply chain module. Distribution, production plan, resource, and operations plan will let you work with that sales and operations planning. Then you've got the planning elements that can cause MRP to be problematic. Those are involved in 1.4.7 or the item planning maintenance. If you look at these elements, planning, lead time, order policy, order periods, safety, stock and lead, minimum multiples, these all are going to have an effect on how MRP is going to calculate, as you saw from our MRP grid. So all planning and manufacturing functions use this item or item site planning data, and you should become familiar with each one of those. The 7 significant factors to consider in MRP are lead time accuracy, both supplier and manufacturing, on-hand accuracy, we talked about cycle counting and physical inventories last month, how you forecast, whether you take into consideration seasonality, what your order history is, your accuracy of purchase orders and work orders and sales orders, your capacity, although MRP doesn't deal directly with capacity, the proper statement of capacity in QAD is going to assist in the accuracy of your MRP system. And then obviously your BOM and your subassembly dependencies based on that. So the item data is involved in that 1.4.17 planning. If you use 1.4.17 or specific item site data, this is where you're going to maintain that. And also in 1.4.16, 18, and if you use the service support module, you're going to use look at 11.3.9. So if you use multiple sites, you should make effort to make sure that the PT master records coordinate with the PTP .DEET and the PTI.DEET, or the planning and the inventory detail records associated with 1.4.17 and the specific sites. There are order policies and order multipliers in MRP that affect how the calculation is going to take place. There's basically 4 types of order policies. There's lot for lot, which says if you got a requirement, you're going to plan an order. There's a fixed order quantity, which relates to the EOQ. Talk about that in just a second. And then period order quantity, which is the MRP explosion that I showed you with the planning to support the net requirement by going out X number of gross requirement periods to accumulate those into a planned order. And then you've got your order multipliers, minimum, maximum, and multiple. There are also, if you read the Apex body of knowledge, there are other lot sizing techniques, least unit cost, least total cost, part period balancing. If any of you are familiar with Wagner Witham, I've seen companies actually program these into the MRP calculations. So if you need to, you can enhance the order policies for that. EOQ is the basis of most of your order policy questions. It's the classic Apex formula, twice the annual usage times the setup divided the carrying cost for dollars, or twice the annual unit usage times setup divided by the carrying cost times the unit cost. So you calculate your annual usage, you figure out what your setup is, you calculate your carrying costs, how much you pay your warehouse guys, what does it cost to keep your forklifts, etc., as a decimal, and then what your unit cost is. That then calculates what that EOQ formula is, or if you want to put it into 1.4.7, that would be your FOQ value. And you can see here that that FOQ would be based on either EOQ, or you can modify the order policy in MRP by either looking at order minimums or order multiples. If you use lot sizing, if you don't understand how EOQ works, probably best to understand that. You need to calculate these values, the calculation of order and carrying costs. You need to understand how your order modifiers are being used, if you've got any minimum requirements from your suppliers, what your order quantities or multiples from suppliers, and then an incorrect placement of POQ. And I mentioned that simply because I've run across a couple of clients in most recent history that use POQ for every single part in the system. And that is probably not a good approach to how to use order policy. And the failure to actually calculate EOQ. Lead time is another major element of MRP. You've got your manufacturing lead time, which is made up of 5 elements: queue, wait, setup, run, and move. Purchasing lead time, inspection lead time need to be set accurately, and then your cumulative manufacturing lead time, the system will calculate that for you, and time fences and horizons. Those are all dependent on your calendar maintenance and your holiday maintenance. If you don't do proper tracking and calculation of lead times, that can lead to MRP telling you completely inaccurate and not up-to-date information. So you need to track the actual purchase lead time and track your actual manufacturing lead time, then update that in your 1.4.17. Safety stock is used to calculate against the variability of the system. This has to do with the frequency, your service levels, the length of the lead time, and its relationship to the forecast intervals. So you calculate your safety stock and then input that into the PT safety stock value in 1.4.17. And if you use safety lead time, which basically offsets your planned order release by that date, then that's going to affect how MRP is going to calculate. So you need to understand the safety stock equation, surface factors, mean absolute, lead time to ratio. You need to measure your forecast error. That means you need to know what you forecast last month and what you actually sold last month. Are you going to use safety lead time? Safety not up to date. Buyers and planners are responsible for updating MRP with those values. And remember, in the MRP grid, if you calculate a 0 net available and you put in safety stock is now that new net available value. There's the BOM, and if we look at the BOM, we've got the parent and the component relationship. Those need to be absolutely accurate. The quantity per, this is critical to MRP. That is how MRP is going to explode the requirements from the parent. You've got start and end effectivity. I see a number of companies not paying attention to start and end effectivity dates. That doesn't allow MRP to plan very well. You've got scrap factor, which we'll talk about in just a second. Lead time offset can offset the lead time of a particular component to parent assembly. If you use forecast, We'll talk about forecast simulations in just a second. There's where you're going to put your forecast percentage. If you use formulas, formula is basically the same as a bill of material, only this is more of a recipe or a formula for the bill of material processing, and this has to do with the quantity type. If you use blank on the formula maintenance, it's the same as the bill of material, but you can set it by batch size or even percentage of batch. So this allows you to do a little bit more refinement for formulas and recipes in QED. You've got phantom assemblies, which can cause MRP to either pay attention to or ignore quantity on hand. You've got global phantoms, which are at the item master level for all BOMs. And you've got another parent component relationship phantom, which is controlled at the BOM level. So this is basically how we guard against overly structured bills of material in MRP. Yield is the ratio of usable output from a process relative to its input, and that is controlled at the item level in 1.4.7. You can see here the yield percentage, and what that does is it adds a gross requirement based on that yield percentage to the MRP calculation. You've also got scrap, which is at the parent component relationship, and this is going to recalculate the gross requirement explosion of the parent to the child. So you can see here in our 13.5, we've got the parent component relationship and the scrap factor. So that's going to play on how MRP processes. Product change control. Product change control in QAD PCC is made up of groups, routings, product change requests, product change orders, and that is going to play on how you control the bills, the routings, and the actual work orders and purchase orders that exist in the system at current. So if you do that inside QED, you're going to use the PCC process, but you can also use Agile, Arena. I know lots of companies that use that, Winsong, Siemens, lots of different tools to use that. But if you don't have some sort of product change control on your MRP data, you're going to get out of phase with your planning data, your BOMs, your work centers, your sales orders, your work orders, repetitive schedules, purchase orders, inventory. So you need to have a process in place to account for change in the MRP plan. Reasons for BOM issues in MRP: incorrect statement of parent component relationship. Here's the biggie: incorrect quantity per. Whether you use formulas, your structure types, which talk about scrap, lead time offset for forecast percentage, and phantom items. When we look at demand in MRP, the gross requirement, if you remember from our discussions of forecast, two types of demand: independent demand, which is the whim of the customer, and dependent demand. This is the demand that is derived by the parent component relationship. Those are going to be treated by MRP with very specific techniques, forecasting techniques at the independent demand level and BOM structures at the dependent demand level. So here we've got forecast driving material requirements planning in 22.1. This is your forecast maintenance. This is where you're going to input your forecast by period for the items that you're going to sell by part number, site, and year. If you use exponential smoothing or alpha factors, you can use the 22.7 forecast simulation. Went through that late in 2018. These procedures allow you to use historical data in QED and store the forecast results. And they're based on a number of different methods of forecasting that you can use in material requirements planning, and you can develop your own if you feel the need to. So if you don't do forecasting, if you're not measuring actual demand and you're not comparing it to forecast demand, you can't have your mean absolute deviation, which is going to be paramount in your calculation of safety stock, going to affect your EOQ. You need to arrive at a consensus quantity for your forecasting. That's why you do sales and operations planning above MRP. You need to both consider subjective and objective forecast, and you need to understand your math models. What kind of formula are you going to use? Exponential smoothing, double exponential smoothing, regression analysis, etc. So we'd highly recommend that you use that 22.7. So some final thoughts on forecasting. Don't forecast if you can calculate it. Don't confuse forecast with sales quotas and budgets. They're not. Consider both extrinsic and intrinsic factors, and remember, forecasts are always wrong. So don't waste your time trying to make it perfect. Forecast on shortening lead times so the forecasting becomes less important. Sales orders, if you drive sales orders are the primary tool that we use to drive demand in MRP. You create those in 711. This creates a gross requirement in MRP, and you can see that in your MRP grid, that's going to be part of your gross requirements, which is going to calculate to your planned orders and your reschedules. Sales orders in sales order maintenance, sales order master, sales order detail. You've got due dates, whether you consume forecast allocation days. At the line level, you've got units of measure, detail allocation. So all of those are going to play on how that sales order affects MRP. You can also have customer schedules. Customer schedules are a primary tool for the automotive section. This is going to get your demand from the customer. You're going to create a required ship schedule. You're going to run MRP, create, send the shipment notice, and the customer is going to receive the process. So you've got incoming data from customers. You've got outgoing data, shipment transactions, which are going to affect how MRP treats those customer schedules, both in terms of dates, demand, quantity on hand, EDI, automated ship notifications, etc. Shipping, if you use 7913 and 7915, sometimes called the old shipping method, that's going to decrease what MRP sees on hand, and it's going to increase your accounts receivable. If you use the advanced pre-shipper or advanced shipping notice with the pre-shipper automatic, your workbench, and using 795 confirmation, this is going to affect the quantity on hand and allocations for MRP. So shipping affects MRP, quantity on hand, the gross requirements, allocations, required dates, and the timeliness of shipping all affect how MRP is going to calculate. Quantity on hand, if we look at the perpetual record, which we talked about in January, here we have the continuously updated quantity on hand. So the continuously updated quantity on hand is where MRP starts. So if we've got 500 on hand and we've got some allocations, we're going to place an order, we're going to issue some parts and receive some parts, we can see that that calculation of that quantity on hand is going to determine where MRP starts its calculation from. So this perpetual record needs to be pretty much 98, 99% accurate. We talked in January about that quantity on hand, transactions, cycle counting, physical inventory. If you look at the transactions, receipts, issues, transfers, these all are going to affect MRP. So you need to understand all of these transactions, what the debits and credits are, what quantities get reduced and what quantities get increased. So if you don't have control on that, MRP is not going to calculate very well. I won't recommend a barcode system, but Eagle, Freedom, the automated solutions from QED, Radley, there are other barcode systems. Barcoding basically means better transaction control. So if you don't do barcoding, you're at the mercy of your shop guys and your warehouse guys and their inaccurate handwriting and timeliness. With barcoding, you've got a much better chance of having accurate data for the MRP process. You've got a cycle count. You've also got to do physical inventories if your audit terms require that. That's going to affect your quantity on hand. If you order parts, which we all do, that's going to be done in 5.7. So the purchase order creates a scheduled receipt, that paperwork released. You can see here that we've got a purchase order which increases the scheduled receipt on the MRP grid in the receipt row. If you do the purchase order receipt, that is going to reduce the order status or the order on status in the MRP grid and increase the quantity on hand. So that receipt for purchasing is going to increase the quantity on hand and take away or reduce the visibility of that scheduled receipt in the MRP grid. So purchase orders that affect inventory, buyer planner responsibilities, who does what, inaccurate maintenance of open quantities and due dates. This is critical. This is one of the things that Alan Dunn talks about in his expose on the coronavirus impact on supply chain. How you do receiving, return status, supplier schedules all affect MRP. If you use supplier schedules, the schedule is created and you send it to your supplier. Supplier then ships your product and you receive it either through an ASN or through a manual process, which thereby increases the quantity on hand. So you create the need, you run MRP, you create the schedule, you send it to the supplier, they pick, ship to you, and you receive. So all of those elements affect how MRP is going to calculate. You've got the update of quantity on hand and due dates, receipt processes, MRP with locations, restricted transactions, which we talked about previously, and your inventory status processes. If you use subcontracting, your supplier lead times, the updates of POs and work orders, the receipt transactions that are done for subcontracting are going to affect MRP. Work orders, you get your information from item data, product structures, work centers, routings. The work order header has your work order number, your quantities, items, required dates. At the line level, you've got your items and your quantity required, your component due dates, which affect how MRP is going to calculate. The shop packet is critical because that's what is going to flow through your shop and control the flow of the paperwork that accompanies the actual product that you're producing in MRP or in the shop floor control process. You've got 16.13.1 work order bill. This controls how MRP sees that parent component relationship in the work order. When you issue the work order in 16.10 work order component, that's going to reduce the quantity on hand of the component in the MRP grid and eliminates the work order component value. The work order receipt is going to produce an RCT-WO transaction in 3.21.1, and you can see that's going to increase the quantity on hand and decrease the scheduled receipt for those assemblies. Work order elements that affect MRP are have to do with how you create the work order bill, the work order component issue, print and release, and the work order receipts. Those all deal with your due dates, your components, quantities, allocations, issues to work orders, receipts, open quantities. So if you don't pay attention to work order types, to work order statuses, if you don't keep your due dates and release dates up to date and process your transactions properly so that you get accurate values of open quantities, completed quantities, MRP also uses that work order routing data for CRP, which we'll talk about in just a second. So incorrect values in your work order elements are going to play on how MRP reacts. If you use repetitive for high volume, high degree of control types of products that are all used by the same process, if you want little paperwork and you're going to work on a schedule, not a work order, that advanced repetitive is probably an excellent tool to use. Finite scheduling, you can create multiple orders very easily, auto backflush of labor. You can do rejects and rework of WIP. You can scrap parts, track inventory, and it's a very flexible accounting process. The 1822 2.4 explodes your schedules in MRP, and then by use of 1821.118, you can update your orders in MRP so that it recognizes what those schedules are for your scheduled receipts on the MRP grid. The backflush transaction in Advanced Repetitive does both reporting of production as well as issuing of material. So here you've got ISS-WO, RCT-WO, and if you're doing it in other sites, you can do transfers, but this is going to affect your quantity on hand and the open schedules for your MRP process. And so the elements of repetitive that affect MRP are the quantity cumulative orders, your schedules, and your backflushes along with your dates of transaction. In shop floor control, you got to have accurate data. You've got to have an attainable master schedule. We've talked about that before. If you don't, your priorities will not mean anything. You've got to have an appropriate definition of work centers. You've got to have scheduling and priority rules, your order release control. We saw that lead time setback for the components and accurate production status and updating. The shop floor control has, in most companies, 80% of the activity on or affecting MRP. So you've got to have accurate routings for your op history transactions, your labor and movement, and for your TR hist, which is going to be your ISS and transactions. MRP plans orders and recommends rescheduling. We've got a couple of rules of misalignment that MRP does. Here I've got a chair and the arm. I'm going to bring down the requirements of the arm from the chair, 2 per, and I've already got scheduled receipts out there, 250 and 50. So the rules of misalignment are, if you encounter a negative projected quantity on hand in a period inside of a scheduled receipt, MRP says it's easier to expedite than to delay. So you get an expedite message. MRP assumes you're going to do what it says. So you now got 150 available in period 3, 50 in period 4. Now I've got another scheduled receipt of 50. I've got a requirement of 100. I've got 50 available, so I don't really need that 50, so it's going to give me a delay message. MRP assumes you're going to do what it says, and if I encounter a scheduled receipt in which the gross requirements all the way through the horizon don't have any requirements, it's going to give me a delay message. So those are the rules for misalignment. Planners need to understand how those work, and the messages are then controlled through the planned order, repetitive schedule approval, work order approval, and purchase order approval. So you've got to do this every day. MRP planners have to pay attention to these planning notices every single day. There are over 50 action message types in MRP, and you're going to use action message menus to control and update the releases, the firms, lead time violations, reschedule, in, out, cancel, pass through, exception. So those planning messages are going to be critical to your successful use of MRP. Capacity requirements planning. MRP is what is called capacitive insensitive. MRP has nothing to do with capacity. So you need to do rough cut capacity planning above MRP, and you need to do capacity requirements planning below MRP. You've got to use 24.1 to recalculate the plan. You usually do that every time you do an MRP explosion. And then there's the 24.5 input-output control, which allows you to keep detailed visibility of what your process is out on the shop. There are many tables that are related to MRP. BOMs, formulas, inventory, master schedule. It's a good idea that your planners and everybody in the organization understand all of these tables and the fields that affect MRP and how to make MRP work correctly. 32Soft has a number of data loaders. I'm sure most of us who have used QAD know it's a little bit problematic to get all of this information into QAD and process, but 32Soft has a number of data loaders. Just get a hold of Nancy or Alex or Denise or I, and we'll be glad to explain that, how that might help. So we've talked about a lot of stuff over the last 30-40 minutes. MRP, control files, planning. Any one of these, in particular, some can cause MRP to calculate differently or even incorrectly. Understanding and the correct application of these concepts can make MRP do what it is intended. That was and is to create a plan that can be executed successfully. So we saw how MRP works, and we've talked about the factors that can adversely affect the impact of the accuracy of that MRP plan. So if you've got any questions, please, Denise, you can take it back and we'll see if there are any questions.
Real quick, let's just take a look at what we have coming up next. We have our previously scheduled April 22nd webinar, again, the second one for this month. That's QAD's service and support module. And because there is a good deal of content, we have split this topic into 2 webinars. So managing warranties, contracts, and returns will follow in May. Although there is some topic synergy, of course, these are independent webinars. Is that correct, right, Don? So yes, you can attend May without having attended April's webinar.
And just a word about the service and support module. It is a robust, complex module within QAD, and you don't actually have to use all of the functionality in MRP or in service and support. There are many of the tools, material orders, RMAs, that can be used by companies that don't use warranties, contracts, etc. So even though a lot of companies don't use service and support, it is it's my favorite module, and there's lots of good stuff that is applicable in that.
And that says a lot. I knew you were a big fan of it, but I did not know it was your favorite module, Don. How about that?
Yeah, it is. I spent 5 years with Eaton Corporation in implementing service supports across many of their sites. So yeah, it's it's a good good tool.
Great. Great.
And
So we
also,
do hope.
just a reminder, if anybody is interested in that information that Alan Dunn presented on the COVID-19 global supply chain impact, just send Denise and I a quick note, and we'll be glad to forward you that.
Yep. I do know that some of you are registered already, so I wanted to also note that our adjusted schedule has, here it is, more tips to manage QAD inventory now on June 17th, and that will be followed by QAD purchasing, new ideas and practical tips in July. Registration is open for all 4 of these webinars, and links to register are available on our website and at the bottom of all of our communications. So that's just our quick look ahead. Now back to today's topic. And yes, MRP is complex, but simplicity could only have been bought at a great price in accuracy.
Yes, pretty good.
Okay, that is all we have for today. Unless you have anything else you wanted to add on, we'll go ahead and wrap up.
No, just please be safe, and again, social distance, and just wash your hands and
all those good guidelines. Yeah. Yes, thanks. Thank you, everybody, so much for your time today. We're glad you were able to join us, and certainly we hope you'll return for our webinar on the 22nd. Until then, have a super day, and as Don said, keep safe and keep healthy, everybody. Thanks again, and have a great day.
You have a great day. Thank you, guys.